In this video, we will share about the moisture and drying analysis. Moisture content is one of the most frequent measured properties of food materials. It is important to food scientists for various reasons such as legal and labeling requirements, economic, microbial stability, food quality, and food processing operations. For most food products, water is one of its major components. The choice of the method of measurement is affected by the expected moisture content of a food product. The approximate expected moisture content of food also can be used as a guide to determine the required practical level of accuracy when measuring moisture content relative to other food products. There are three forms of water in foods: free water, which acts as a dispersing agent for colloids and solvent for salts, adsorbate water, and water of hydration. Distillation method developed as quick methods for the use of quality control work. It is an approved method for spices, cheese, and animal feeds. Principles in this method are: involve the separation method of moisture with sample by distilling the sample and immiscible solvent with higher boiling point than water, but less dense than water. Then the flask containing the mixture of sample with solvent is attached to the condenser by side arm and heated. The water in the sample evaporates and moves up into the condenser. Then when it is cool, it is converted back into liquid form, which then flows into the graduated tube. Lastly, the volume of water in the graduated tube is measured when the distillation process completely stops. One of the examples of distillation method is din and start method. The advantages of distillation method are: it is suitable for application to foods with low moisture contents, the equipment is relatively cheap, easy to set up and operate, and it is suitable for application to foods containing volatile oils such as herbs or spices, since the oils remain dissolved in the organic solvent and therefore do not interfere with the measurement of the water. However, this method is not applicable to some types of foods. It is also destructive and relatively time-consuming. Meanwhile, for chemical method, there are two types of method could be included. The first one is Carl-Fisher method, which is the most accurate method in determining water in food with low moisture content. Second, the titrometric method, which involves iodine with sample water, presence of alcohol solvent, sulfur dioxide, and base. The principle of Carl-Fisher method involves reduction of iodine in the presence of water by sulfur dioxide. Then, water will react with iodine and sulfur to produce sulfur trioxide and hydrogen iodide. The endpoint reached when all the water is consumed. We have two different techniques for water determination in Carl-Fisher. First, volumetric method that appropriates for sample with moisture content greater than 0.03%. Second is colorimetric, appropriates for sample that have very low moisture content from 0.03% down to ppm. For the advantages, Carl-Fisher titration has extreme accuracy because it is upon a chemical reaction which depends upon the presence of water. On the other hand, colorimetric titrator has advantages to detect free water, emulsified water, and dissolved water, unlike other methods, even at low quantities. It also avoids the need for tighter determination and is thus an absolute method, with the amount of current consumed being exactly related to the amount of iodine generated. However, they also have disadvantages such as the margin of error is relatively large when manual volumetric Carl-Fisher titration is applied to material that contains starch. Carl-Fisher titration also depends upon a redox reaction, and thus any component of the sample, which is an active redox chemical, will react with the iodine in the reagent and generate false result. Lastly, moisture adhering to wall of the unit can be one of the source of error. Thus, all glassware and utensils must be carefully dried.